Hi guys, I hope you're having a good day. Los Angeles is cold, just like it is here. Here's your notes for 6.6. It's called the Proportionality Theorems, and then the substitute hopefully will put up the notes again so you can copy them down if I move too fast. I already tried to videotape this once, and so unfortunately I'm just going to uncover what I've written so far. Here's the first theorem that you're given. All right, so let's say you have this triangle right here, and then you have this extra segment TU that attaches to the other two sides of the triangle. What this theorem states is that if you know that QS is parallel to TU, then the sides are cut proportionally. So that we know that RT over QT is this equal to RU over SU. And I've written that right here. That this piece of this side over this piece of the side has to be equal to the big piece of that side over the little piece of that side. There is also a converse of the proportionality theorem. So I'll give you a second to write that down because I've already written it down. The converse states that if we know that the sides are already cut proportionally, then these two lines have to be parallel. So I'll write that here. If a line divides two sides of a triangle proportionally, I abbreviated that, then it is parallel to the third side. So here's how it's used. Unfortunately, it's not super nicely, it doesn't come out to a nice answer, but if I know that these two lines are parallel, 44 over 35 has to equal 36 over x. Or vice versa, I can even say 35 over 44 is equal to x over 36. So I set up a little proportion over here. I said 44 over 35 equals 36 over x. Used my cross product, which is not very pretty, and I got a number out that was not, it was 315 over 11, or approximately 28.64. Not very nice answers. All right. There's another theorem, and this is a no-name theorem. So let's draw a picture. I'm going to draw two lines that are not parallel, all right? And then I'm going to draw three lines through that, okay, that are not equally spaced. And I'm going to call this point U, point W, point Y. I call this point V, X, and Z, each of those points. Okay? And I'm going to tell you that these three lines right here are parallel, right? That's what these little triangles mean. These three lines are parallel. So what this other theorem states is that if you have three parallel lines, so let's write that. If three parallel lines intersect two transversals, then they divide the transversals in proportionally. They divide the transversals proportionally. So what that means is, for example, UW over WY has to be equal to VX over XZ. For example. So this little piece over the big is the same, would have to be equal to the little piece over the big. Okay? And then I'm going to turn this over for the last part, the last theorem. The last theorem states, okay, so let's take an angle. Let's draw an angle. Let's do that. If I have a ray that bisects an angle, so here's a ray. I'm bisecting this angle, and let's call this angle C. So let's start that. If a ray bisects an angle, okay, if a ray bisects an angle, and then I'm going to make this into a triangle. Okay, so actually the ray can continue on. I'll call this A, call this B, and we'll call this point D. So if this ray bisects this angle, then it divides the opposite side, so this side, into segments that are proportional to the two other sides. So I'm going to write that down and then I'll give you an equation. Then it divides the opposite side into segments who are proportional to the other sides, to the other two sides. Okay? So what I mean by that is, since this got bisected, so angle C got bisected by ray CD, that segment AD over DB, so this segment over this segment, has to be exactly the same as CA over CB. Okay? So I'm going to let you practice this with a worksheet, and then you'll have a book assignment. Reminder, I'll write this here, reminder, there'll be a chapter 6.1 through 6.3 and 6.6 quiz on Monday. Hope you have a good weekend. Send questions on Edmodo. Please be specific, as I will not have a book with me. See you guys later.